Alright, so we're talking about the Butler SP1Z zipper splicer. It's a semi-automatic zipper splicer because the operator needs to be involved. When the running roll expires, the operator needs to take the tail of the running roll, put it into the heat splice head. The heat splice head will join it to the new roll of material, and then pressing the run button on the control panel will allow the new roll to start feeding into the process. In the meantime, in typical Butler fashion, we have an accumulator in the back of the system that you see here that will continue to feed the process at steady state while the splice is being made. Depending upon the speed of the process, the operator could have anywhere from 1 to 2 minutes to prepare the splice after the old roll has expired. I'm going to go ahead and start the system now. It will start feeding from this roll, and then we'll go ahead and make a splice into the other roll. So you see the roll of material is now feeding the accumulator. Material is not being pulled from the accumulator right now, so I'll start our rewind system. So we'll start pulling material, and you'll be able to see this feed material at the correct rate. So now you'll see that the feed roll has sped up. It's now feeding enough material to not only feed the downstream process, but also to backfill the accumulator so you have enough material there to feed the process. So the accumulator is now full of material, and the material is being fed from the running roll. It's pulling it, matching the process speed to keep the accumulator full at a steady state with a maximum amount of storage, so the operator has 1 to 2 minutes to prepare the next splice. So while the new roll is running, the operator would replace the expired roll with another new roll, and they could go ahead and prepare one side of the splice. So what we'll do is we'll trim this off. Our trimming tool here, get a nice square end. We'll go ahead and place both ends in the splice head. So the splice head has alignment marks that are etched in there that match the profile of the zipper being used on the splicer. Helps the operator not only align the splice, the material, but also has an overlap section where the heat bar will perform the heat splice. So at this point, the system is ready for the operator to take the tail of the old material when that roll expires, place it into the splice head, and do the heat splice while the accumulator feeds the main process. There's two different ways the system can be triggered to go into auto splice mode. The primary way is to use this light sensor here, so when the tail of the material comes off the roll and passes through this light beam, when the light beam no longer detects the material, it will automatically clamp the nip, isolating the front of the machine from the back of the machine and allowing the operator to take that tail and make a new splice. You can also base it on calculated diameter of the roll, so if you'd like to do the splice when the roll gets down to a particular diameter, the system is continuously calculating the roll diameter. When you get to the splice diameter, it will automatically nip. So what I'm going to do to expedite the process is I'm going to go into manual splice mode, which is another way that you can activate a splice. If you decide you want to expire this roll and move to the new roll, simply hit splice mode on the HMI. The nip will close, again isolating the feed part of the process from the accumulation side and back. We'll go ahead and hit splice mode now, and you can see we've stopped feeding material into the process. So what I'll do is I'll create the tail that we normally would have seen here by cutting this material off. This would have broken the light beam or passed through the light beam. The operator would then take this tail, trim it off square, because the ends are usually not square, and then place this in the splice head in the same manner they did for the new roll that they had put in previously. So good. We can clamp this in. We have it overlapping on each side. We're using the guides with the spline going through the slot in the head and the guides lining up each edge. You have a nice overlap. Close the head and turn the heat on. The door is interlocked while the heat cycle is in place. It runs through a heat cycle as well as a cooling cycle to prevent any injury to the operator. It will only unlock when the cooling cycle is complete. At that point, you can open up the splice head. The operator would then rejoin the zipper material as it had been previously. And if you look in the back in the accumulator, you'll see the accumulator is rising because it's continuing to feed the process. So the process has not seen any degradation of material being fed into it. We'll go ahead and web this back in. We'll take a little bit of slack out of the roll, close the splice head, and it's now ready to start feeding from the new roll of material. The operator would then press run on the HMI. And what will happen now is the accumulator will rise to a predefined location near the top. We will pull from the new roll of material, get the splice through as quickly as possible, so we'll maintain that accumulator position as close to the top as possible until the splice has gone through. And then once the splice has traveled all the way through the accumulator, we'll then start backfilling the accumulator back to its full position. So you can sort of see the splice moving through now. It's about halfway across the accumulator. You can kind of see it each time it comes through here. It's moving around to this section now. And we're slowly filling the accumulator again. This allows us to get the splice through the system as quickly as possible, so you don't have to wait for all 100 plus feet of accumulation to pass through the system. And now it's being fed from the new roll of material, and the process will just repeat where this new roll of material will run at a speed slightly higher than line speed, backfill the accumulator so it's prepared to have material to feed the process when the next splice cycle comes.